Hi Engineering Janta, I am Vaibhav Shukla and today welcome you all to the episode 7 of Statistics for Data Science, which is the WTF series. Every Wednesday, Thursday and Friday I come here and teach you statistics for data science. So we'll start our note from where we left it. We'll start our discussion from where we left it in the last lecture, and that's percentiles. We'll go ahead. We'll start learning from percentiles, but the primary topic that we'll cover today is the 5-number summary. And before we delve into that, go ahead, tell me in the live chat section whether I am visible and audible clearly or not. फटाफट बता दो. Type a yes if I am visible and audible. If I am not visible and audible, then tell me that I am not audible. Confirm if I'm audible. Just type a yes if I'm audible. Guys, am I not audible or the chats are delayed? What is the issue? Confirm it fast. If I'm audible, then we can begin the lecture. No. If I'm audible, just type a yes in the chat section. Okay, so we are visible and audible, and the primary point is, I guess, chats are taking time. Okay, voice is not louder. Fine, fine. I got your chats, I got it. Fine, chats are delayed, I guess, a bit. Thank you, Mohammed, and thank you, Akshay, for acknowledging. And Mohammed, I hope now I am audible clearly. Chalo, padhna shuru karte hain. Without wasting any time, let's start studying. Fine. So, we left the discussion at percentiles, where we learned that percentile, what exactly is a percentile? For example, I'm saying that somebody has scored 92 percentile, then 92% people of the whole data set are lesser in the terms of performance than that particular person. Fine. So what exactly is percentile? It is a value below which certain number of or certain percentage of values of a data set lie. Is it clear? Okay, there are a few things, few people are dropping yes. I guess there are a few delays in the chat section, I guess. Okay, fine, fine. Guys, let's concentrate on studying. So I'm writing the percentiles definition again. It is a value below which percentage of certain observation lies. Fine. So basically it is a value below which certain percentage of a few values or a percentage of certain values lies. Fine. We had studied percentage, we had seen its formula, but what if I tell you that this percentile that you're trying to calculate, we had studied percentile as well, and we had studied the formula for percentile, and at that point of time, one thing that I didn't tell you was that percentile is an instrument to find out location in the data set. So basically it points out to a location in the data set. For example, I say value at X percentile, fine. Now how do you, or let's not take X, rather let's take some other variable, because earlier we had taken X variable for the value, you will get confused. So value at kth percentile, fine. If I want to check that out, how will I check it? Value of kth percentile, fine. The formula for this is k upon 100 into n plus 1, fine. Now if you've carefully studied the last lecture, you'll realize that this n plus 1 is an addition. Basically this plus 1 is not needed, simply n could have worked. Why so? Because percentile calculation kaise hota hai? Let's check. Percentile says, the formula for percentile rank is into 100. N is total number of values, total number of values below X. If this is, let's write it even better, fine. So I'll write it even better. Total number of values below X upon n into 100, fine. This is percentile rank for any given data point X, fine. Any data point which is X, for it, if we are calculating the percentile, then total number of values below X upon the total values, which is n, into 100. This gives you percentile rank. Now if you see, a lot of people would be confused that why not get the value at kth percentile with cross multiplication, because here we have percentile, you multiply it by n, divide by 100, and you'll have the value at percentile. Will you have that? No, you won't. You'll have total number of values below X, but here you're trying to calculate the value at kth percentile, fine. So if I suggest, let's take an example. We have this example, say this is our data set 4, 5, 6, 7, 9 and 11, fine. This is our data set. In this data set, if I tell you give me the value at 70th percentile or 70 percentile, fine. So what would be the value at this? Value at, fine, this would be nothing but 70 upon 100 into n plus 1. Now what is n? 1, 2, 3, 4, 5, 6. n plus 1 is 7, fine. Now this is the kth percentile. What I'll do is I'll divide it. This gives me 7 7s are 49, 4.9. So this gives me value at 70th percentile is 4.9. Basically it says at this particular value you're going to have 70% data below this, fine. At this value 70% of data is below this particular value. Is it true? Now there's a catch in this. When you're trying to calculate this, value, we added 1 here. We had 6 outputs, we added 1 there. Why did we add this 1? The very simple answer to this is, जब हम percentiles की बात करते हैं, so you have from 1 to 100th percentile. If I do not add this 1, what would the formula look like? K upon 100 into n. This would be the formula because I'm not adding n plus 1. Now what if this kth output is actually the 100th location? What if I tell you that? Then this would become 100 upon 100 into n, then this would be nth value, fine. If this is the nth value, then for 100th percentile, the last value will have 100 percentile. If the last value is having the 100th percentile, in basic statistics, it says that it has performed even better than himself. That cannot be possible. By statistics, that cannot be possible. That is why n plus 1 is being added. Now, if you got this logic, great. If you didn't get this logic, you can simply note down this formula. You do not need this formula exactly. Okay, simply note down करके रख सकते हो. Whole point of telling you this was, if somebody gets the logic of it or somebody is asking for the logic, then this logic can help you out. Fine. Now let's move forward. Let's move to the 5-point number summary. Fine. For this, you need to understand that in this there are 5 values that we are trying to get. One is minimum value, another is Q1, which is quartile 1, we have spoken about it in the previous video. Then you have to check median, then Q3, and then maximum. In this scenario, let's take a data set where you are having, say, 4, 5, 5, 7, 9, 11, 12, like this, values like this, and one value in this should be something like 37. Fine. Now when you have these values at your disposal, what I'll do is, first of all, before calculating anything, you know Q1 is quartile 1, the 25th percentile, Q3 is 75th percentile, right? This is 75th percentile, this is 25th percentile. Fine. So basically what do quartiles do? Quartiles do this. If these are the values that are plotted, then quartiles divide the data set into 4 equal halves. Fine. So this kind of 4 equal, pardon, I've not drawn good 4 equal halves. I'll rather take them away. So this is 50th percentile, this is 70th percentile, and this is 25th percentile. Fine. So these are Q1, Q2, Q3, and beyond this is Q4, which is the quarter which is lying. Primarily these are the lines which give you quartiles. This is Q1, this partition, this is Q2, this is Q3, and then Q4. Fine. Now interestingly, if you see, what we need to calculate is minimum value first of all. In the first eyesight, the minimum value you can see is 4, the maximum you can see is 37. But in this data, there is an outlier which is 37. Now how do you calculate this outlier? How do you figure out that what exactly Shashank, very good, you're right. So how do you figure out what exactly in this particular scenario is outlier? Just by looking you cannot say it is an outlier. How do you do this? For that, what you should do is, you should rather have an idea of 2 things. You should have idea of what exactly an outlier is, number 1. Number 2, you should have some reference from which you can calculate that this particular value is an outlier. Now you should have some basic value, you can have some basic value above which you can consider outlier or below which you can consider outlier. This much is clear? Chat section में फटाफट बताओ. Is this clear? By far, is everything clear? Okay. So fine. So now what I'm going to do is, we'll have here, you have 2 values primarily, Q3 and Q1, which can help you out here. Fine. What you can do is calculate lower fence and a higher fence. Now what these values are, I'll tell you. These will help you detect outlier, that would help you detect maximum and minimum values. So what is lower fence? The formula for lower fence is Q3 minus 1.5 into IQR. Fine. Pardon, not Q3, this is Q1. This would be Q1. And higher fence. Lower fence is here. See, in lower fence is on this side. Fine. Higher fence is on this side. Fine. So here, when I talk about higher fence, this becomes Q3 minus, pardon, plus 1.5 IQR. Fine. Now what is this IQR? What do you mean by this interquartile range? Why isn't it letting me write? Fine. My God. This is not letting me write, so let's try something else. Fine. So what is this IQR? This IQR is interquartile range. We have spoken about it. What is this interquartile range? This is nothing but difference between the Q3 minus Q1 values. So the value at Q3 percentile minus value at Q1 percentile. Fine. Is it clear? Now generally when you calculate the values at that particular percentile, it gives you location of that area. Exactly, Shashank, this is interquartile range. Now when I move forward, what I'll do is, I'll first of all calculate this Q3 minus Q1. Fine. We'll try calculating this. How do you calculate this? Value at Q1, what it would be? 25 upon 100 into what is the total number of values? 1, 2, 3, 4, 5, 6, 7, 8. Now if you correctly see, these are 8 values, so I can multiply it by 9. But here there is repetition of elements, so whatever we get would be a location, a position. At that position we are going to check a value. Fine. For example, 1, 2, 3, 4, 5, 6, 7, 8. So you have 9. That's true. We have done right. And now this is nothing but 1/4 of 9. So what is 1/4 of 9? This is approximately somewhere around 2.25, if I'm not wrong. Is it? 4 2s are 8. Yes, 4 2s are 8 again. And then yes, 2.25. So what I'll do is, I'll check somewhere here. Fine. I'll take these two values and then I'll take the mean of them, which is again 5. So the value you have at Q1 is 5. Fine. The value you have at Q1 is 5. Now the value at Q3. So this is value at 2.25th location. Fine. Value at Q3. Whenever there is repetition, remember this formula will give you the location for data. Fine. Now when you come to value at Q3, what would it be? 75 upon 100 into 9. Again when you come here, this is basically 3/4. Fine. This is 3/4 of 9. You need not do anything, you just multiply this 2.25 by 3. So what does it become? 3 5s are 15, 3 2s are 6 plus 1 7, 3 2s are 6. So 6.75. Fine. 6.75 is the location, 6.75th location. So what I'll do is, I'll go here 1 2 3 4 5 6 and I'll take 6th and 7th, 11 plus 12. So I'll do the average of them, 11 plus 12 by 2. So this becomes approximately 23 by 2, and then 23 by 2 is nothing but 11.5. Fine. So now you have values with you of Q3 and Q1. What I'll do is, so now we have actually done two things in number summary. We have calculated this Q1, we have calculated this Q3. That much is clear. Now coming to minimum and maximum, how do we calculate it? Without removing outlier, you cannot calculate the maximum or minimum values because outlier will give you the wrong data. So when I calculate this interquartile range that I just explained you, Q3 minus Q1, what will be that? The values here are 11.5 and 5. So 11.5 minus 5, which is nothing but 6.5, and then I'll go ahead, I'll check for the lower fence. So lower fence is, the value here is 5. Fine. 5 minus 1.5 into interquartile range. Fine. So I'll calculate this with the most powerful tool for an engineer, that is calculator, isn't it? Let's check with it. So 1.5 into 6.5, that becomes 9.75. So 5 minus 9.75, and this is nothing but minus 4.75. So this is your lower fence. Any value below minus 4.75 is an outlier. Got it? Now calculating the higher fence. How do I get the higher fence? First of all, the value for Q3, 11.5, value at quartile 3, 11.5 plus 1.5 into 6.5. This is nothing but 1.5 into interquartile range. So 11.5 plus 9.75. Now when I add them up, what does it become? this becomes 21.25. Now any value above this number should be eliminated because it is an outlier in the data. Fine. So you got your lower fence, you got your higher fence, you got any value above 21.5, or what was that, 21.25. Fine. Any value above 21.25 is an outlier. So check which value is above 21.25. This value. You simply remove this value. Once you remove this value, now the data set you have is a balanced data set, and for that minimum is 4. Fine. And this 12 is maximum. Fine. This is the maximum value. And if I try calculating median, now see 1, 2, 3, 4, 5, 6 and 7. So this becomes the median here because this is the middle value. 3 values here, 3 values there. Had I taken 37 into account, my median would have changed. 7 plus 9 divided by 2, that would have been my median. Fine. So now you have maximum, you have median, you have minimum, you have Q1, you have Q3, and that's pretty much about 5-point number summary. Itna easy hai. This is so easy. Fine. Itna easy topic hai. This is very easy topic, easy to understand, easy to get. Fine. Now anyone who wants notes, all you can do is simply go ahead and comment below this video, number 1. Number 2, you will get this PPT as notes in my Telegram community. So if you want that, ask for that in the comments as well. But dear CST team, I would request you to put my community link in the chat section so that people can access that out and they can have an access to that link and join that Telegram community. That Telegram community would help you out. Fine. I hope it has no doubts. If it has a few doubts at your end, go ahead, shoot up with those doubts. I'm here to take them up. But before that, keep doing good for others. Good will come back to you, as I always say. Now shoot up your doubts and then we'll wrap up this session. So go ahead. Shashank is asking, sir, if I have 1 lakh of data in that 19,000, what to do, whether should drop or cap? Shashank, I'm not able to understand what exactly you're asking. Can you elaborate more? But I hope that you're asking that if you have 1 lakh in the data where 19,000 is average value, this is very, very strange. You have given just 2 values. How can I tell you that about whole data set? What's the scenario? You completely elaborate the scenario. I'm waiting. Fine. You go ahead, type it out. Shashank, if you're asking that it is something where maximum data is near 1 lakh and one data is 19,000, then definitely it is an outlier and you'll have to eliminate it. Fine. If maximum data is around 19,000, 1 lakh would be an outlier, you'll have to eliminate it. Fine. I hope that clears your doubt. So if it is clear, Shashank, please put a yes. If it's not, then also tell me what exactly your doubt is so that we can wrap this session up. Okay, you have data set with 1 lakh records. Okay, and I identified 19,000 as outliers. I'm considering whether to drop or drop or keep them. Okay, Shashank, now what you should do is, now this is a very interesting question. If you're having 1 lakh records, see, in 1 lakh records, having 19,000 records, as outliers. This is what you have, this much records you have as outliers. Pardon, I've written it wrong. I should write it in this manner. Fine. So you have approximately 1 lakh records and you have them as outliers. So what you are actually getting is 19% of data. I'm not talking about percentile, this is percentage. 19% of data is problematic. You cannot reject it. As simple as that. This is not a smaller chunk. You have 19% data. Now, if it is not relevant, go ahead. As a data scientist, you have to look at the factors that whether the data I'm having is relevant or not. If it is not relevant, you can skip that out, remove that out. But a general practice is ask for the corrections in the data. Fine. If they are still the outliers, remove them out. At least don't train the majority chunk on a wrong portion. Don't throw it under the bus. I would suggest if you have no option, then remove it. Otherwise, ask for the corrections in these 19,000 values. Otherwise, the only way is you remove them. Further, we have a few ways of handling outliers. I'll tell you those once we study some further concepts. Fine. So I hope that clears your doubt, Shashank. फटाफट बताओ यार. Is it clear now? Say yes or no. Great, Shashank. Great. Fine. So on this note, I'll wrap this up, and to all of you, I'll say keep preparing hard, keep working hard. Very soon you'll land up at your dream destination, and wherever you can spread this knowledge, go ahead, spread this out. Keep doing good for others. Good will come back to you. Thank you so much. Thank you everybody. Thank you demo channel. We'll meet you tomorrow with a new topic, and it's a very interesting topic, so stay tuned for that.